on you. You don't have to pull out a calculator or anything. I'm going to do all the graphing for you at the board. We have the parent function. And what I'm going to do is I'm going to show you what the graph of negative x squared looks like. So I have the parent function graph right here. Again, same thing you have on your paper. And when I graph here the equation that's on the board, I forgot, I forgot to make it. I know what I'm doing, I promise. Equals. There we go. What happened to these graphs? It reflected. Where did it reflect? Over the x-axis. So somebody asked in the last class if I had to have those parentheses there. So let's see. If I delete the parentheses, did it change the graph? No. So for now, if I have the negative dot in front, it looks like that graph reflects over the x-axis. So let's write that down here. It reflects over the x-axis, and I want you to actually graph that on the paper that you have. So take every point and just make it the mirror image of itself over the x-axis. Think back to last year's class, which we won't name, and think about how you, because every time I say it, you guys get mad at me. So think back to last year, how you reflected things over the x-axis.
What was last year? I'm kind of confused. Like geometry?
That one.
Ew.
Oh my god, geometry.
Ew.
I like geometry.
I didn't have a problem. Of course you did.
Although I will be honest, I did not really care for geometry when I was in high school. Like I grew an affinity for geometry when I was in college.
But I'm also a math.
Alright, so we're reflecting over the x-axis. You're all good with that. Now let's look at the other one here. I'm going to graph y equals, I'm going to put parentheses around the negative x. Well, I have two graphs on the board, but what do you notice about them? It's the same. So if we're talking about reflections today, what kind of reflection do you think happened to get the same graph? So I started with the original, right? Here's my original, it's blue. I click on the reflected graph and it's the same. Yeah, reflected over the y-axis. So why, if I take this graph and reflect it over the y-axis, why does it look exactly the same? It's symmetrical. A parabola is the same on either side, so if you reflect it over its axis of symmetry, it is the same. So that's our next one here. This graph is reflected over the y-axis. Now, do I have to draw that on my graph? No, because it looks exactly like this one. And now, y-axis, it's hard to see with parabolas because it looks the same. We will use the y-axis here, like reflecting over it for some things, but we're going to see it more later in the year when we get to graphs that look like this. This is called a square root function, y equals the square root of x, and we're just going to look at the same thing here really quick. So I'm going to graph negative square root of x on, oh, I'm not tall enough, there we go. Negative square root of x, wrong button, here. What happened again from the red to the blue? It reflected over the x. So it looks like the negative in front moves you over the x. So we'll write that here. And you can make that graph again. So you'll reflect each point over the x-axis. We'll get a nice little pretty sideways parabola now. Now this one's going to be a little easier to see, the next part. When I graph the square root of negative x, so this time the negative is under the radical. And when I graph that, it's a lot easier to see which reflection now. So this way, I reflect it over the y-axis, and it's a lot, you can visually see what's happening here. So there we will say we reflect over the y-axis, and I'll use a different color. We go the other way now. Not too hard. The first couple days of these transformations are pretty easy.
It's super hard.
Shifting, reflecting is not that bad. What we're going to get to tomorrow and then the next day are a little bit more complicated. Slightly. In terms of graphing. So let's talk about the rules here. When you have a negative in front of everything, so you have a negative and then your parentheses and all your stuff, that is reflecting over the x-axis. When the negative is inside the parentheses, that is reflecting over the y. That's just something you need to memorize. Okay. So now let's put this onto our transformations chart. Okay, so we're looking at the next two boxes on your chart. Same kind of thing. We just want them all in one place. The negative in front reflects over the x-axis. You're changing it vertically. You're going from up and down to upside down. If the negative is in the parentheses, you're going to reflect over the y-axis. The negative slides. And when you're ready, you can flip your notes paper over. I'm guessing like 5 more minutes here. Super pretty quick. Ease it back into, which one am I on? This one. Too many smartboard tabs. Alright, so now we're going to make some pictures. So we're not just going to go left, right, up, down. We have to identify the transformations, make the pictures of the graph. So when I look at A, I have negative the quantity x plus 3 squared minus 1. Where is the vertex for this parabola? Yep. Okay, so let's graph that. We're at negative 3, negative 1. So this helps you see, too, when you plot it, what transformations happened. Let's start. When we list transformations, I like to start on the left and hit every number and sign as we go to the right. So the first thing I see when I look here is a negative out in front of everything. What transformation does that look like from your chart when the negative is in front? Reflect over the x. So that's the first thing that happened to this graph, is we're going to reflect over the x-axis. The second thing that happens, this next thing we come to is the plus 3 inside the parentheses. What way does that move your graph? Which way? Left. Remember, the inside your parentheses is the opposite of what you think. The plus means left 3, but we can kind of see that when we look at our vertex here. If I typically start at the origin, my new vertex is to the left of where I start. And then the minus 1 means you went down 1. Okay. Well, now starting at that vertex, we are going to graph the parabola. I haven't done anything in terms of the length of the parabola. Nothing is different. We haven't learned that yet. So all we have to do is basically do the pattern for the parent function upside down. So when we go out 1, instead of going up 1, we're going to go down. So go ahead and let's plot as many points as you can that are going to fit from your parent function pattern. 5, 6, 7, 8, 9. And you're going to make a nice, pretty parabola. So as long as you still, we talked about this Friday, know the pattern of the parent function, the graphing should be too hard right now. Okay. You good so far? Alright, the next one we have the quantity negative x squared plus 4. So let's first talk about where the vertex is. Is there a number after the x in the parentheses? There's a 1 in there? Like, does it say the plus 1? It's 0. This is like negative x plus 0 right here. So this x coordinate is going to be at 0. Where's the y coordinate? 4. So you know your vertex is at 0, 4. We can plot that point. What does the negative inside the parentheses do to your graph? Reflects it over the y-axis. So when I do make this picture, after I write this down, does reflecting over the y-axis actually change, like, anything about the parabola? No, it's not going to change our parent function. It's still going to be facing upright. What does the 4 plus 4 do? moves it up 4, right? The number that's outside of the parentheses, the plus or minus at the end, moves you up and down. So now all we have to do is plot the rest of our points. Out 1, up 1 on either side. Out 2, up 4. And then that's your vertical. Not too bad so far. All right, one more.
This is actually awful. So hard.
So hard.
Yes.
Well, that's why we call it Honors Algebra 2 for that reason, huh?
We're gonna drop out of school.
I don't think this would be the class dropout number. All right, negative x squared plus 6. Where is the vertex of this graph? 0, 6. Okay, so we know our vertex is here at 0, 6. So we just have to decide what is happening to our graph so that I can make the picture. The negative is in front. It's not inside parentheses. So what does that do to the graph? Reflect over the x-axis. There we go. And then plus 6 on the end? Up 6. Okay, so I already did the up 6 part, so all I have to do is the upside down part. So now you just follow the parent function pattern the other way. 5, 6, 7, 8.
Why is it down?
Why is it what? Down because when we reflect it over the x-axis, I'm looking like this, and I flip it upside down. So technically we flipped it, and then we moved it up 6. So the transformations go from left to right. Like it actually is kind of like, you know, like the order of operations, you have to follow a particular order. You do for transformations too. It's always the left to the right. Okay, not too bad. We have one more set on the bottom, and then we're done. Something a little bit different though. This time we're given a parabola to start with. Same parabola on either grade. Okay? So from this parabola, we are going to write the equation of the parabola, and then we're going to reflect it and write the new one. So we're just practicing writing vertex form equations basically here. So let's look. I don't care which parabola you look at. Where is the vertex of that parabola? Yep, negative 2, 6. Okay. Now when I write the vertex form for this parabola, the first thing I do notice when I visually look at it is that it's upside down. What do I do to my equation that makes the graph upside down? A negative, yeah, a negative in front. So that's the first thing you have to write is that it's negative. That's the flipped upside down part. Then the rest of it is going to look the same for vertex form. So if I have a negative 2 as my x-coordinate, what's going to go in the parentheses? Plus 2, and then the y, or the outside, will be plus 6. Okay, that's the equation that you start with. From here on out, we're going to adjust that parabola. On the left one, it says take that parabola and reflect it over the x-axis. So we did this earlier. Take every point here, and I want you to find where it would be when it reflects over the x-axis. So you're going to be the same distance away on either side. There, I think that's right. You shoot a parabola that kind of looks like that. So if you're 3 above or 3 below the x-axis, then you're now 3 above the x-axis. And now, we're not really worried about the original equation. All I want you to do is look at this new green parabola and decide how would you write the vertex form for that equation. So the first one is, where is the vertex of this new green parabola? Negative 2, negative 6. Okay, now is this parabola upside down anymore? No, so you do not need a negative out in front. You just need y equals. What would be inside the parentheses? X plus 2, right? It's the opposite, minus 6. And that's the whole thing. So far? All right, one more. Let's reflect the next one over the y-axis. And honestly, the biggest mistake with this topic that people make is they mix up the x and the y-axis. Most of you are fine. So you're going to move all these points over. Let's see. Here and here. All right. It's not a very pretty parabola, but
That's beautiful.
really.
Yeah.
I think it's kind of like an ugly duckling of parabolas. It's not that bad, but it's uglier than the green one.
No.
The green one's better.
I don't think so.
I have high standards for parabolas, I guess.
Yes, it's alright.
I know. I thought about it, but it's okay. Alright, where's the new vertex of this parabola? 2, 6. Positive 2, 6. Now, is it upside down? It is. It's still upside down. So when you write your new equation, you have to have a negative. Now, I know we reflected it over the y-axis, but I'm not worried about the transformation, like putting a negative in parentheses. Not that. I just want you to tell me what is the equation here. So you don't have to like put a negative x in parentheses. How would you just write the equation if you just looked at this big graph? You'd have a negative and then what? X minus 2, good, plus 6. And that's it. Not too hard today? All right. There's a little bit of practice here. My suggestion is that you at least